Welcome to Lesson 8 of Module 3, Linear and Quadratic Systems. So we've solved linear systems and we've solved quadratic equations. So now we're just going to put those two together. So what are linear quadratic systems? A linear quadratic system involves one linear equation and one quadratic equation. Solutions are the points of intersections between the line and the parabola. So just like with linear systems, the solution was the point of intersection. We're looking for the point or points of intersection in this case. So there can be two solutions, one solution, and no solution. So there are two solutions if the line intersects the parabola two times. So if you look at the first graph here, here are your two solutions, the 2 points of intersection. There's one solution if the line is tangent to the parabola. So tangent, a tangent line means a line that touches the curve once and only once. And no solution is if the line and the parabola never intersect. So there are a few ways that we can solve linear quadratic systems. And the first way I'm going to show you is algebraically by substitution. So let's say we have this system here. Y equals x squared plus 2x plus 1 and y equals 3x plus 5. We can solve by substitution by setting the equations equal to each other, right? Since y equals x squared plus 2x plus 1 and y also equals 3x plus 5, we can set the two equations equal to each other and solve for x. So now that we have the equations equal to each other, what we want to do is move everything to one side of the equal sign and set the entire equation equal to 0. So we'll subtract 3x and subtract 5 on both sides. And we get x squared minus x minus 4 equals 0. Now we're going to use the quadratic formula to finish solving. So remember, after setting the equations equal to each other and using inverse operations to set the equation equal to 0, we're left with this quadratic here, x squared minus x minus 4 equals 0. If you notice, this is a polynomial, a quadratic that we cannot factor, right? So we're going to use the quadratic formula here. So our a value is 1, our b value is -1, and our c value is -4. Substituting into the quadratic formula and simplifying, we get this right here. 1 plus or minus the square root of 17 over 2. Now, if you're just using the graphing calculator and putting it in like I showed you how to do, you're not going to get this expression here. You're going to get a decimal, and that's great because in the next step, I want us to approximate the actual x values. So we're going to approximate the solutions now. So all we're going to do is, you might be there already if you put this into the calculator, but if you simplified it step by step, what we're going to do is we're going to put 1 plus the square root of 17 over 2 and then 1 minus the square root of 17 over 2 into the calculator, and we're going to round to approximate the solutions. So doing that, you should get x is approximately 2.56 and x is approximately -1.56. So now we have our x values, right? But remember, it's a system of equations, so the solutions are the point or points of intersection. So we're looking for coordinates here. We're looking for ordered pairs. So we have the x values of the points of intersection at this point, and now we need to find the y values. So we'll find the y values by substituting our approximations for x into both equations, right? Just remember, x is approximately 2.56 and x is approximately -1.56. We're going to substitute both those values in for x. So if we use 3x plus 5, and substitute, we get y is equal to 12.68. And when we substitute negative 1.56 in, we get y equals 0.32. So you can choose, right, which equation you want to substitute into. I chose 3x plus 5 because it's a linear equation, it's simpler, and just easier to solve. So what are our solutions, right? We have our x values, we have our y values. How do we express our solutions? Our solutions are ordered pairs. Remember, they're points on a graph. So the solutions are 2.56, 12.68, and negative 1.56, 0.32. So to be honest, substitution in general is just not my preferred method, but since substitution is such a reoccurring theme in algebra and in math in general, I do find that many students feel comfort in substitution. So that's why I'm showing you. Just my personal opinion, substitution is not my preferred method. It took us 4 kind of long, tedious steps to get to the solution, and I just don't think that it is the most effective way or most efficient way to utilize your time. But if you like substitution and you know how to do it, by all means, use substitution, right? The best method is the method that works best for you. Please pause this video and work on the Lesson 8 Level 1 problems in the workbook. In Level 2, we'll look at the graphs of linear quadratic systems. So graphing is actually always my preferred method of solving. I think that looking at something visually is the best way to learn, but I'm a visual learner in many ways, so that's just my opinion. So let's take a look at this question here. If xy is a solution to the given system of equations, what is the product of the y coordinates of the solutions? So we have the system here, x squared plus y squared equals 9, and x plus y equals 3. So what do we need to do here to answer this problem? It's asking us for the product of the y coordinates of the solutions. So we need to find the solutions, or most importantly, we need to find the y coordinates of the solutions, and then it's asking for the product. So that means that we have to multiply those values. So what I love about this new digital SAT is that the application that you're using, Blue Book, the calculator that it gives you is Desmos, right? So I encourage you to utilize Desmos as much as possible on this SAT. So you're going to use Desmos on Blue Book. The great thing about Desmos when it comes to graphing, as opposed to your TI-84, if you want to graph something on your TI-84, it has to be in y equals, right? The graphing function on the TI-84 is the y equals button. Now, both of these equations are not set equal to y. In Desmos, you can graph any equation in any form. You can literally write in x squared plus y squared equals 9 into Desmos, and it will graph it for you. You don't need to solve it, and you don't need to isolate any variables. So I would use and abuse that feature. So when you graph these two on Desmos, you'll get something that looks like this, right? You get a circle and a line intersecting that circle at 2 points. And the points of intersection, or the solutions, are at 0, 3, and 3, 0. So they want the product of the y coordinates. What are our y coordinates? I'm going to call y1, the first y coordinate, 3, and y2, 0. Those are the y coordinates of our solutions. So they want the product of the y coordinates, so we'll multiply 3 times 0, which is 0. Please pause this video and work on the Lesson 8 Level 2 problems in the workbook. In level 3, we'll continue to look at the graphs of linear and quadratic systems, and we'll look at equations and graphs that are a little more complex. If xy is a solution to the given system of equations, what is the product of the x coordinates of the solutions? So this is similar to the previous question, except now we want the product of the x coordinates. Again, these two equations here in the system, 7y squared equals 50x minus 150, and y equals 3 minus x over 2, they look like complex equations, but you can just put them into Desmos, right? Use Desmos on Blue Book. Use and abuse Desmos, right? You can put these equations in just as they are. No need to rearrange. And when you graph them on Desmos, you should get a graph that looks like this. So our points of intersection, or our solutions, are at 3, 0, and at 31.56, negative 14.28. So they want the product of the x coordinates of the solutions. So x1 is 3, x2 is 31.56. All we're going to do to answer this question is multiply 3 times 31.56, and we get 94.68. Please pause this video and work on the Lesson 8 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next one for Lesson 9.